Hello everyone, this is Shyam Babu, Assistant Professor, Electronics and Communication Engineering Department, MLR Institute of Technology, Hyderabad. Today we are going to discuss the topic is generation of AM waves or AM modulators. Then observe, mainly before explaining the generation methods of modulation schemes of AM, first of all, you need to understand the definition of amplitude modulation. What is the amplitude modulation means? The amplitude of the high frequency carrier signal is varied according to instantaneous values of the message signal. That means, again I repeat, the amplitude of the high frequency carrier signal is varied according to instantaneous values of the message signal. That means the modulation process is happened means definitely need two signals. One is message signal, nothing but our information signal, and the second one is the high frequency signal, that is the carrier signal. Therefore, as per the definition, the carrier amplitudes is varied according to the message signal amplitudes. I am showing, observe here, when I am taking this is the message signal, it is the low frequency signal. The high frequency signal is nothing but a carrier. The amplitudes of the high frequency signal is varied according to amplitude levels of the message signal. It is called as a amplitude modulation. This is nothing but a AM wave. This is nothing but a AM wave. Then, what are the methods we have to follow to generate amplitude modulated wave means? Basically, there are two ways to generate the amplitude modulated signal. Then observe here what are those two methods. One is non-linear modulators and the second one is linear modulators. What are the non-linear modulators? Examples are square law modulator and balanced modulator. And the linear modulators are, you have to go collector modulator. Then we discuss the one by one. Then what is the non-linear modulators? Basically, as per the definition of the diode, considering the practical diode, a diode is a non-linear device. That why when designing a circuit for generating the AM wave with the help of non-linear devices, the example should be diode, transistor and field effect transistor, nothing but FET. Here, it makes use of the non-linear characteristics of the non-linear devices. Same as to make the device operate in the non-linear VI characteristics. Once observe the VI characteristics of the PN junction diode, we are using the diode on that case. What is the non-linear means? When you take the x-axis in voltage and in y-axis in current, it is non-linear means this is nothing but a non-linear. What is the linear condition means? This is the linear nature. What are the examples of the non-linear modulators? We have basically square law modulator, it is a non-linear, and also we have the balanced modulator is also a non-linear modulator. The switching modulator is another example under a linear modulator. Linear modulator. Then go for the next one. What is linear modulator? It makes the use of the linear region. What is the linear means? If you take the VI characteristics, voltage and current characteristics of the diode, the linear characteristics is nothing but when voltage is increases, parallelly the current is also increases. That means here the thing is not regarding to the Vi and I. We are using the non-linear device or a linear characteristics of the devices to derive the modulated signal. Here the which modulated means amplitude modulated signal. That means here the input is kept high to operate the device in the linear region of Vi characteristics of the diode. That is the difference between linear and non-linear. What is the example here? Linear, a switching modulator is the example for the linear modulator. That means the non-linear modulator is nothing but a square law modulator and balanced modulator, and a linear modulator example is a switching modulator. In this session, we are discussing about one example under non-linear and one example for linear modulator. Go for the first one. Non-linear modulators, the example is square law modulator. The name indicates square law. Square law. Here, observe here I am taking the two signals because the modulation happens with the message signal as well as carrier signal. M of t is the message signal. You know very well M of t is mathematically can be representing am cos omega mt or am sin omega mt, and it is like a M of t message signal in time domain. And go for the carrier signal, that is nothing but a AC cos omega ct or AC sin omega ct, and this is C of t. C of t. Then observe here where omega c is nothing but angular frequency, that should be equal to 2 pi fc. 2 pi fc. In this circuit, we have the different blocks. Observe here M of t and C of t can be summed using the summation, and we have the square law device and followed with the band pass filter. Observe here the basically S of t is nothing but a amplitude modulated signal. Amplitude modulated signal. Then what is the amplitude modulated signal means? Observe, I need to find this is amplitude modulated signal. How we can get, I explain. Then let modulating and carrier signals be denoted as M of t and AC cos 2 pi fct, nothing but C of t, nothing but message signal and carrier signal respectively. These two signals applied as the input to the summer, therefore this is one M of t and this is C of t. These two is applied to the summer. Then the output should be equal to V1 of t. Then V1 of t is given to the square law device. Is given to the square law device, then that output should be equal to V2 of t. That means, observe here, V1 of t is equal to M of t plus carrier signal, because V1 of t is nothing but M of t plus C of t. It is the summation. That's why M of t plus AC cos 2 pi fct. This V1 of t is applied to the input to a non-linear device like a diode. That means here I am taking this is a non-linear device, like example is diode. Then V1 of t is given to the diode. Then the output is come to the V2 of t. What is that V2 of t? V2 of t is nothing but K1 into V1 of t and K2 into V2 of t. Because here the K1 and K2 are a constants. It is a constants because we are processing from one block to another block. Then V2 of t is nothing but, observe the where we are right now, present here I am, because V1 of t is the one output and it is the input of the square law. The square law device output should be equal to V2 of t. Then V2 of t is equal to K1 into M of t. We had already message signal and summation with the carrier, and K2 into M of t plus AC cos 2 pi fct whole square. This is very important because we are applying to the square law device. That's why the square is happens. Then V2 of t is equal to, I am multiplying here, K1 M of t, K1 AC cos 2 pi fct plus k2 m square of t plus here a plus b whole square, a square plus b square plus 2ab. Then I am elaborating each one. Then v2 of t is equal to k1 m of t, k2 m square of t, k2 ac square cos square 2 pi fct, and k1 ac 1 plus 2 k2 by k1 m of t cos 2 pi fct. Observe the entire equation of v2 of t. This is the high frequency signal and this is also very high frequency signal, but we have only the amplitude modulated signal. What is that? Amplitude modulated signal. Then these high frequency signals can be neglected. Then what is the remaining should be equal to, observe everyone, what is that? K1 AC 1 plus 2 into K2 by K1 m of t cos 2 pi fct. Therefore, we know very well what is the definition of amplitude modulation. The amplitude of the high frequency carrier. Here the amplitude of the AC is nothing but a high frequency carrier signal amplitude is varying according to instantaneous values or amplitude values of the message signal. Amplitude values of the message signal. That's why out of entire V2 of t, we taken only the last term. That's why the last term of the above equation represents the desired AM wave. What about the remaining three terms means? We know very well. We having the amplitude modulated signal, it is a low frequency. The squaring term should be very high frequencies. That's why we neglected. And first three terms of the above equations are unwanted. So, with the help of band pass filter, we can pass only AM wave and eliminate the first three terms. Then observe here the diagram. V2 of t is passing through the band pass filter. We know filter removes the unwanted signals. What are the unwanted means? K1 m of t, K2 m square of t, and K2 ac square cos square 2 pi fct. These three terms can be eliminated with the help of band pass filter. Then what is the remaining? K1 into AC 1 plus 2 into K2 by K1 m of t cos 2 pi fct. This is nothing but a amplitude modulated signal. It is generated by the non-linear device. That is the example under the square law modulator. Then what is the last one? S of t is equal to K1 into AC 1 plus 2 K2 by K1 m of t cos 2 pi fct. What is the standard equation of AM wave? S of t is equal to AC into 1 plus Ka m of t cos 2 pi fct. Once compare these two equations, S of t, the standard AM equation versus the square law modulator output waveform V2 of t is passing to the band pass filter. After that S of t, that you compare, then what is the difference here? Both are maximum same. Where Ka is nothing but a amplitude sensitivity. You know very well Ka is 2K2 by K1. This is nothing but non-linear device with the example square law modulator to generate amplitude modulated wave. Then go for the another method to generating amplitude modulated signal. Always remember, what is the amplitude modulated signal? S of t is equal to AC into 1 plus Ka m of t cos 2 pi fct. Okay, you need to get this equation at the final. That is nothing but amplitude modulated wave or amplitude modulated standard form this is. Then observe here, I go for the linear modulator. The example for linear modulator is switching modulator is one example under linear modulator for AM generation process. Here also I am taking the two signals, one is M of t and second one is C of t. M of t is the message signal and C of t is the carrier signal. It is AC cos 2 pi fct. These two are given to the summation and we go for the V1 of t is the output, likely square law modulator. And here what is the main difference between square law modulator and the switching modulator is only one block. The square law modulator is replaced with switching diode. You know, as per the electronics point of view, we have some basic fundamental definition statements. The diode as a switch, the transistor as an amplifier. Therefore, here I am taking diode and it is used for switching. You know very well, when diode should be on condition means it is nothing but switch on. When diode is off means the switch is open. The switch is on means the flow is happens into the circuit. When switch is off means it is a open circuit, there is no flow of action is performing into the circuit. This is the basic idea. With respect to that idea, I am explaining clearly. Here I am taking the switching modulator. I am taking the two signals for the modulation process. One is M of t and the second one is C of t. Is given to the summation. The output should be equal to V of t. V1 of t is given to the switching diode. Is given to the switching diode. Then observe here. This is the switching diode. This is the M of t and this is the C of t. Then with respect to the high frequency and low frequency, or the high voltage and low voltage, then the switch is closed and open. The switch is closed and open. That means switching modulator is similar to the square law modulator. The only difference is that square law modulator, the diode is operated in a non-linear mode, whereas in the switching modulator, the diode has to operate in ideal switch. The voltage rises, the current rises. That's why it is a linear modulator. Let the modulating and carrier signal be denoted as M of t and C of t. You know M of t should be AM cos omega mt, AC cos 2 pi fct respectively. These two signals are applied to the input of the summer. The summer block produces the output should be V1 of t. V1 of t is equal to M of t plus C of t. Here I am taking only the carrier amplitude is varying, that's why M of t plus AC cos 2 pi fct. Then this signal V1 of t is applied to the input of the diode. Assume that the magnitude of the modulating signal is very small when compared to the amplitude of the carrier signal, because the carrier amplitude is varying with respect to the message signal. So the diode's on and off actions is controlled by the carrier signal only. The diode's on and off action is controlled by carrier signal C of t. What is that? That means when C of t is greater than 0, it is nothing but, as per the electronics point of view, high voltage, nothing but a forward bias. And C of t is less than 0, nothing but it is a 0 voltage or a negative voltages. It is nothing but a reverse bias. Under the forward bias, we have knowledge on electronics. The diode is a closed switch. Under the reverse bias, the diode is a open switch. Therefore, with respect to carrier amplitudes, with the high level, it is the diode should be closed. And with low level, the diode should be open. Therefore, the output of the diode is V2 of t is equal to V1 of t if C of t is greater than 0 and 0 if C of t is less than 0. Then this is the generation methods. I am taking one example under non-linear model and I am explaining another example under linear. In the case of non-linear, I explained about a square law, and in the case of linear, I explained switching modulator. Okay. Next sessions we are discussing about, right now generation is explained, then From amplitude modulated signal, how you can get the message signal. The process is called as a demodulation. In coming session, I want to explain demodulation methods of AM. Thank you very much.